Alright, welcome to part 3 of our video. Please ensure to like and subscribe to our page. We'll be looking on several questions regarding the CSEC physics topics as well as CAPE topics. Alright, so welcome to part 3, and here we have 3 forces now, and we're expected to find the resultant force as well as the direction. Alright, so we're going to start off by actually drawing up back our table here. We're going to have vectors. We're going to have our x component. And we're also going to have our y component. I'm going to call this one A, this one B, this one C. So looking at A is kind of a special case. Notice that this is a 90-degree angle. So once we have a force here under this scenario, it has no y component. The elevation is nothing. So this 14 is actually going here, and if you wanted to do it, you could put your cos, and you could say 0, 14, and you automatically get that 14. If you really want to do it, you could have put your sine 0, and this is equal to 0. So we know that there's no elevation there, and it's going in the positive direction. So that takes care of that. Looking at B now, B is going downward. It's not going to go downward. It's also going to the left. So we're going to have negative 8 cos 45. And we're also going to have negative 8 sine 45. So we're going to have bit. We're going to have an equal. Let's look at C. C is going in terms of the x direction, that's going to be a negative as well. It's going to be negative 6 cos 45. And it's going to be, I'm going to put my equal there. And it's going to be positive 6 sine 45. We're going to calculate these, put them in the calculator, and then we're going to write the values we get there. And then we're going to deal with the Rx and as well as the Ry. Give me a second to grab my calculator and calculate calculations. Alright, I've gone ahead and just calculated that for us. Let's find our Rx. Give me a second. And our Ry, we're going to add up everything. We have a 14 plus that minus 5.67 minus that 4.24, and we end up with this being 4.09 newtons, and on this side we have 5 minus 5.67 plus 4.2. So we end up with minus 1.43 newtons. Alright, pause if you want to take that down. We're gonna go ahead, let's go ahead and draw that. So we're told that, hey, in the x direction, when we draw this, we're gonna end up with 4.09 newtons, and we're going 1.3 newtons down. So Rx, Ry, and we have a resultant force going this direction. Our angle is gonna be to the horizontal. Complete that, more point that, and I'll go ahead and erase this. Grab my eraser, and let's find the resultant as well as the direction of our resultant. Afterwards, we're just going to jump straight into answering 2 past paper questions from the CXC CAPE past paper, and then we're going to wrap up this series on resolving forces. Alright, So we know that if we are gonna find a resultant force, sorry about that, we're gonna have Rx squared plus R all squared, and Rx is 4.09 squared plus minus 1.3 squared, and let's find our square root of that, and we'll get the value of R. So let's jump on my calculator and get that for you. Alright, so we have done that, and let's find direction. So our direction is gonna be our opposite over our hypotenuse. My angle being here, my opposite angle is gonna be that. So it's gonna be tan inverse 1.43 over 4.09, and let's get our angle. We'll probably use our calculator and get our angle. We end up with 19.27 degrees, and that would have answered our question or the magnitude and our direction. Let's skip into our other question. Let's see if I can just grab that there. Oh, that's in my way. All right, let me try to grab that. Aha. So this is gonna come into our first CXC question. Let's see. So the question says the diagram represents a box with a mass of 80 kilograms being dragged along a rough surface in the direction of OX. Find the OX component for the 100. All right. It's gonna do it right here. So we know OX. OX is moving this direction. Therefore, we know our angle is to that. Therefore, we know that we're using cos. Alright, so right now to get the value of OX for this one, we'll actually have 100 cos, and that's 34. So that's 100 cos 30. Sorry, rounding there. And we end up with a value of 82.7 newtons. Part 2 asks us for the OX value for 70. So the OX value for 70, same thing, 70 cos 53, and that's gonna be 70 cos 53. That gives me 42.1 newtons. Alright, so we finished that portion there. In a second, I think I need to take this down because I'm going to need it for my other part of my question, and I don't want to waste any time coming back here. Alright, I got it. Let's go to the other part of the question. Oh, we cut out that part of the question. Alright. I guess the question that asks, let me check it out if it's there. If I, oh, it's not. Alright. There's a question that asks, why? So that was why there wasn't any component there. But alright, let's just answer what we asked right now. We'll look at that later on. Alright, the frictional force of this is 30 newtons. What's the acceleration? So this is what we have. I have one force of, let me get this, of 80.29. I have another force of 42.1, and I have a 30 newton force that is heading in this direction. What's my resultant force, or the single force acting on that system there? We know that our resultant force, let's call this our be our net force in this scenario here. Let's add this together. So we have 82.9 plus 42.1 minus our resistive force, and we end up with 90 newton for our resultant force. We know that force is equal to mass times acceleration. From earlier, we're told that our mass was equal to 80 kilograms. It was there. And so we know that acceleration is going to be equal to force over mass. And we know force is 80, or 95. The mass is 80. And we can calculate this. We end up with an acceleration of 1.1875. Let's clean this up. Let's call this 1.19 meters per second squared. And that would have answered our question for that part there. Let me just quickly go back and see if I really chopped off the part of the question that I wanted to look on. Alright. A question, what would it be part 4? Yeah, I really chopped it off. Alright, so part 4 would have asked, why is there no motion in the O? Part 4, why is there no motion in the OY direction? Looking for OY for the 100 degrees, 100 newtons. Let's look at it. Here, let's look for 100, it will be 100 sine 34, and this will be 70 sine 53. What happened here is that when I put 100 sine 34, I'll end up with like 55.9, and when this should be negative because it's going downward now, it's going negative, I will also end up with like 59.9. So negative. So what happens is that the upward forces, two upward forces, are equal and opposite. So one is going this way, one is going that way. So pretty much they cancel each other. And that would have answered the question. The resultant force for the forces that are traveling in the horizontal direction would have cancelled out each other. Alright, we have one more question to look on. We're going to end our video here. So see you next time. Ensure to like and subscribe. Leave a comment in the comment section. And you can send me an email. I'm going to put my email address in the comment section. And we can look at any question you want me to look on. Alright, see you next time in our third and final video on resolving forces.